Hello and welcome to the Data on the Rocks podcast, the place where data aficionados round up, sometimes have a drink, but always talk about data. My name is Florin Tufan, I'm the founder of Solidify, and today's episode is really special to us. It's our first ever podcast and we're extremely happy to announce our first guest, one of the people from whose content I've personally learned a lot from, the founder, CEO, and chief historian of SafeGraph, Auren Hoffman. For myself, this podcast was extremely exciting as I got to ask some of the questions that I think about a lot. From the technical nitty-gritty nerdy stuff, like how do you structure unique IDs and the challenges that come with that, to more higher level questions like the differences between data businesses and regular SaaS. I hope this is as interesting to you as it was to me, and without any further ado, here's the conversation.
Auren, what is the conventional wisdom or advice that you think is generally bad advice?
That's my classic question, right?
Yeah.
I guess imitation is the best form of flattery. It's a good question because first of all, you have to define like what is conventional wisdom, and it's sometimes hard to know like what the conventional wisdom is. So, what's the advice that people often give people, and then like who's the normal taker of the advice? So, if you think of smart people, what do smart people overvalue? To me, the thing that smart people overvalue almost more than anything that they overvalue is optionality. So smart people are always trying to, I would say not all smart people, but most smart people are always trying to increase their options. And I think that makes sense up to a point. And I think smart people have way progressed past that point. So they're all about like doing everything to increase their options and not necessarily picking any direction. They're actually doing things purely to increase their options often, rather than doing things for the sake of actually doing them. And so long term, I think this is it's a bad optimization function that most smart people do.
But would you say there like terms and conditions might apply? Like, for example, some might be counterintuitive. Like, for example, yourself early on, you sort of limited your options, you doubled down on something, and that allowed you to achieve some stuff and then have a lot of options, which are more like in the broader sense of the term options, not so much that you can do whatever you want whenever you want.
Yeah, I think the idea of doing something to increase your optionality, if that's like the reason you're doing it, and this is why a lot of smart people do this, especially earlier in their career, they actually do things to increase their options. That's the main reason. This doesn't seem like a good strategy. And so you in some ways want to do things to decrease your options, like commit to things, etc. You're right, that might give you more broader opportunities in the future if you're successful. But also it may increase the chance that you're successful. Because if you're always like looking over your shoulder for the next thing, it's hard to actually be super successful at something.
And then do you think there's a version of that, and does the same apply to startups? Like a lot of bad startups will do a lot of things early on to increase their optionality, and then the really good startups will like just focus on doubling down.
Yeah, I think it's true also for companies where you want to put yourself in a very narrow box, and that gives you a lot of license to innovate within that box. And it also is clear to every single person in the company what you're doing and what box you're in, so they could be clear about what's going on, essentially what the strategy is. If you're like, we could be building flying cars, but we also could be doing ad tech, and we also have something for your microbiome or something, then it becomes very, very hard for you to innovate in that space.
Okay, and what's the tiny box that SafeGraph is in?
SafeGraph is very simple. We sell data about physical places. So we only sell data, and we only sell data about physical places. So it's a little niche box that we're in.
Okay, so if someone came in and said, let's build a new GPS system, then that would be a very clearly no, they wouldn't even get to the point.
Correct.
Okay. And you decided to start, was it a choice to do a data company before it was a choice to do a company about places, or the other way around?
It was first about a data company. So, I mean, we see a renaissance in the number of companies that can use data, that can buy data, that can have the ability to accelerate projects with data. That is increasing. Just the number of data-oriented people, the number of data-oriented engineers, data scientists, product people, machine learning experts that can use data has been increasing. The amount of tools that they could use has also been increasing. So we thought this is the right time to start a data business. Historically, it has not been a good time to start data businesses. Data businesses have not been, if you think of a data businesses versus SaaS businesses over the last 20 years, there's been like more than 1,000 SaaS businesses that have become unicorns. And I think there's like one data business that was started and that became a unicorn. So it just is historically been a bad idea to start a data business, but we think now is actually the right time to start a data business.
Okay, so what has shifted? Is it only about the infrastructure?
Yeah, there's just like way more people that are data oriented. They're getting better at using their own data. So it doesn't really make sense to buy external data if you haven't even gotten much use out of your own internal data. So the first step, let's say you're McDonald's or something. McDonald's has a lot of amazing internal data. Until you get pretty far along on that curve of using your internal data, it doesn't make any sense to invest in external data. But at some point, you get far enough along the curve where there's only so much more value you can get out of mining your own internal data. And then it actually yields massive value of bringing external data, sometimes marrying it with your internal data to get a lot more value.
Yeah. So
and 5 years ago, even most companies were terrible at even using their own internal data. Today, there's a bunch of leaders that are actually really good at using their internal data. There's still the vast majority of companies that still are not yet at that point where they can use their internal data, but there are now enough leaders to use their internal data that they're getting hungry for external data.
Yeah, so if I understand correctly, there was a time in which, going with your example, McDonald's focused a lot on understanding how each location operates, what's the difference between them, peak hours, bad hours, consumer behavior,
pricing, stuff about employees. I mean, there's so much data they have.
Right, and then there's a point at which it sort of flattens. It's a peak.
Correct.
And then
you hit an asymptote where you can still get value out of your internal data, but it becomes harder and harder to get that value. And at that point, it makes a lot of sense to start bringing in external data. But that's really only the point where it starts making sense. So it really, every company's somewhere along that curve. Some companies are very, very far along that curve. Great, invest in external data. Some companies are very, very early in that curve. Don't invest in external data at that point. You might be 2, 3, 4 years away before you should be doing that.
So at first you focus on really understanding the thing you're looking at, whatever it is. Let's say, where does our revenue come from, in the very sophisticated answer to that.
Yeah.
And then you build the context around it to really understand it. Back to the McDonald's example, then you become interested in what can I know about the neighborhood around each one of my locations, something like that.
Exactly.
Yeah, it makes a lot of sense. Actually, whenever I look at people, so now I'm myself at I'm starting my first company. I started my first company, and whenever I look at the serial entrepreneurs like yourself, I have this question: like at some point, you don't start companies out of a compulsive sort of thought, like, wouldn't it be interested to build SafeGraph? And there's a lot of decision and a lot of opportunity cost that goes into it, and you reach a point where you really understand what that decision means and the impact on your life and so on. And so I was curious specifically about you and in the context of SafeGraph, what sort of made you say, this has enough potential and it's interesting enough that I want to dedicate the next decade of my life to it?
Well, before we started the company, I made a list of what I thought were the most important problems facing humanity, or the biggest opportunities facing humanity. And I was trying to get to the 100 most important problems. I think I got to about 60 or so that I thought were really important. And then what I try to do is analyze each one of them and see if I could have an impact. And those could be from things like life extension to, war and conflict to all these other types of things. And out of and if I was really trying to be very, very honest with myself, there was really only one of those problems that I felt it could have any impact on at all. And it's the problem of like the lack of data available for innovation. And so we are entering a world where we could have one of two outcomes. Outcome one is a small number of companies, maybe 12 companies, control most of the world's data. And that's a world where we're just going to see a lot less innovation, and also a world where the rents to that innovation are going to mostly accrue to those 12 companies. And that's just not a world that anybody wants to live in, including the people at those 12 companies. They don't want that world either. And then we could see an alternative world. An alternative world is where data is open, where any innovator can get access to data. You still may have to pay for it, just like today you have to pay for compute, but compute's open. Anyone can get access to compute. But it's open and easy to access for everybody in the world, any innovator who wants it. And so the gate to innovation is no longer data. The gate to innovation is actually being a great innovator. And that's a much more exciting world. That's a world that's going to lead to a lot more innovation and a lot more democratized of the innovators. And so that was what we decided to kind of dedicate. I'm planning to dedicate the rest of my life to that particular cause.
And one could argue that's very interesting, as you said. So basically, where a great market, a great need, something you resonate with, meets your set of capabilities and sort of unique advantages. So in a way, you thought of yourself like a company entering in a market, but you could argue that there was some location data in some form and some data about places in some form. What was the big gap that made you say, okay, this is it?
Yeah, so again, we originally were focused on data in general, like we need to democratize data. You're a startup, you can't do everything right off the bat. And so the reason why we picked data about physical places, if you think of data, it's really about 4 nouns, right? So you have data about people, data about places, data about organizations or companies, and data about products. So those are the 4 core things that most data is about. It probably 95% of data is about one of those 4 things. Of course, you can cross those 4 things with each other. You can cross those things with time and with price, which so you can get some very, very interesting temporal data or other types of data with time and price. But that really gives you a sense of kind of like the broad things of data. So if you look at those 4 nouns, we had a sense that you had to at least limit yourself to one of those 4 nouns when you're starting. It's too hard to say we're going to do lots of things all at once. We're, at the time, a 1-person, 2-person company. So we need to kind of figure out what we're going to do. And places seem like a really good focus on it. It's a very, very large market. It's a market where most of the incumbents of that market were really focusing on what's called the marketing use case. So that means I'm going to send direct mail to all the sushi restaurants or something like that. In that particular use case, the level of accuracy needed is probably 30 to 50%. You don't need to be very, very highly accurate to provide value in that use case. And that's roughly where the market was. It was when we were testing the market, when we were looking at the market, it was maybe somewhere between 30 and 50% accurate, the data. Or the other use case was actually giving that data to an individual, and that individual is very good at disambiguating like what's wrong and what's right. We wanted to sell it to data engineers, data scientists, machine learning use cases. In that case, you need data at least in the 90% accurate and sometimes in the high 90s, because if you start timesing 0.9 against each other a lot, you get a very, very small number really quickly. So it was just a much, much different expectation of this new type of customer that we wanted to play into.
So so the gap that you saw was this typical. There is some market that has like a very mediocre product, and because the state of the market used to be, or the state of the need and the expectation used to be mediocre, but now there's this new generation of people that has much higher expectations, and there's no one serving them.
Yeah, and I don't want to say mediocre because it serves that need fine. Like there's no need to be more than 40% accurate in that old use case. It gained you a little bit, but it didn't gain you that much, and it certainly people weren't willing to pay for more accuracy. So there was no need, there was no reason to invest in something that was more accurate for that old use case. But for this new emerging use case, there's a much different level of accuracy, and you might be trading off breadth versus accuracy. And people are willing to make that. In the old days, you wouldn't be willing to make the trade off of if in a marketing use case, you're always siding with breadth versus accuracy. In this new use case, you may be more willing to side with accuracy over breadth.
Got it. Okay. Okay, then walk me a bit through how you went about it. Like how did SafeGraph get built? How did you start?
Well, you start very slowly. Data is a really hard thing to do. And the most important thing, people often forget, what's the most important thing about data? And everyone has all these different ideas about it, et cetera. The most important thing, and it's kind of obvious, but you have to state it, is that the data that you tell people is true. If you say this is a fact, ideally, that is the fact. That is true. And of course, if you have billions and billions of data points, you will never be 100% true. That is impossible to be, because even if you were true, even an hour ago, that data may have changed since then. And so, because data often does change. And if you think of any data set that's out there, the data is a living, there's some sort of temporal aspect of it. And so you're always going to be playing catch up. You're always going to be working on it. And so having that will to just focus on we're going to give the highest set of quality facts that we can is really, really important. In some ways, you need to think of yourself as kind of an old school news organization like the Associated Press or Reuters was back in the day. And they're literally, okay, it's just the facts, man. We're just putting out the facts. Someone else can interpret opinions upon this. But if we say like this particular McDonald's in Bangkok opens at 8 a.m. on a Tuesday. Ideally, it opens at 8 a.m. on a Tuesday.
So somebody from McDonald's is gonna get a lot of notifications in their brand mention app. Okay, but that's so. I agree and understand it completely in theory, but when I'm putting the two ideas together, so you start with I think there's a gap in providing really accurate data. And I want to do that, and you're the first one. You're not or one of the first ones. You're not among the 1,000 journalists that reports on the same event. The biggest challenge seems to be like, how do you begin measuring that?
Yeah, it's very, very, very hard. So you need some sort of feedback loop to help you do that, and you can't independently assess every single fact if you have billions of facts. So you need to figure out which facts you're going to independently assess. And that could be you specifically doing it. Let's say you're a company creating these facts. You have some way of independently assessing it. The good news about like a place is that most of these facts are independently verifiable. There are ways to verify these facts. And you get your clients can also help you as well. So if you have clients, especially those clients that face consumers, you have a ready feedback mechanism. And your clients have an incentive to tell you when you're wrong, as long as you have some sort of SLA in place with them to fix those mistakes very, very quickly so that the clients are getting better data in the future. And so you have this kind of reporting mechanism that quickly becomes, in a way, like a data co-op, where every single customer you work with helps every single other customer get better data.
On the entity that they give feedback on, but then can you go back and trace the roots of the decision of presenting?
Yeah, exactly. So sometimes when someone gives feedback on one particular entity, let's say it's the store hours of the local barbershop or something like that, that doesn't help you with any of the other entities. However, in many, many cases, because a lot of these things are done by crawling the internet or algorithmically created, et cetera, like actually fixing one entity could fix 6,000 other entities that are out there. There might be a bug that persists. There might be a lot of other reasons why you're wrong on something. And so getting that feedback could sometimes have a multiplier effect on everything else that you're doing.
Okay, and what's an entity for SafeGraph? Is it a building? Is it a
A place, which is usually a subset of a building. So if you think of a cafe might be like 1/30th of a building footprint or something like that. Now, sometimes a place is a building. So if you think of a big Walmart or something, usually it's like the full building, including like the parking lot around that building or something would be, and even there may even be a gas station adjacent to it, which is owned by the Walmart. And so they have a much bigger footprint that's out there. But often a place is a subset of a building, which could be even in an office building, that could be an office or a floor of an office. There's some sort of other subset that's out there. In the US, there's all these strip malls. A typical strip mall is kind of an L-shaped type of strip mall with like the parking lot in kind of the middle of the L. And then usually in the middle of the L is like a big supermarket, let's say a Safeway or an Aldi or something. And then there's like, a barber shop, a hair salon, a cafe, a juice bar, maybe a gym or something. And they're all of different shapes and sizes. And that's what the types of thing. Maybe there's 14 different stores in that strip mall or something. And that's the type of thing that you want to be able to take a look at.
And did you have challenges where, for example, you'd have like over biased ML models just because it's super counterintuitive that's an over bias? Like
totally.
At some point,
we still have it.
Yeah.
You're constantly having mistakes, and you start correcting things. And for instance, we do a lot of stuff with where we're creating like polygons or shapes of places.
Right.
And so you might get the data from the sky, and you're looking at, maybe you are part of the data from the sky. Your ML models are looking at the air conditioning vents on the ceiling or something like that, of the roof of a strip mall or something. And you're starting to make some cutting up. If you're cutting up these like polygons or shapes, you might be doing that. And then it might turn out that like, well, in Arizona, you need more air conditioning vents than in Chicago or something. And so you may have overtrained it in certain things. So these things actually may be very, very geographic based. Newer buildings may have different types of things than older buildings. Even if you think of Manhattan, so if you think of New York City and Manhattan, well, if you think of like Midtown Manhattan, it's very, very grid based. Everything looks like some sort of rectangle. If you start to go to lower Manhattan, it starts to get like really, all the streets are super funky, and a lot of stores look more like a triangle. And so you go from a rectangle to a triangle in the same city. You just move like a kilometer, 2 kilometers away, and everything changes. So a lot of your models they can't be as rigid. And there's also there's some humility that comes into making these things. There's not like a one size fit all. It's a little bit more like peeling an onion. Where you're constantly have to change it and do things, and then you make something a little bit better over here, and it makes something a little bit worse over here, and you have to be constantly changing and adopting.
So now that you have models that know that not all L-shaped buildings are malls, and I'm guessing it's a lot easier where you have different points of views on the same thing. And you built a number of feedback loops. But when starting to go about the problem, how did you sort of identify what are the initial input sources into the decisioning engine that can provide the best ROI in terms of accuracy? Like it's almost.
You take your guess initially. And you might be wrong, but I mean, look, the nice thing about dealing with like places in the physical world is we're all still operating in the physical world every day. We're not yet like 100% in VR. So we go to the local place. We've traveled, people have traveled to multiple countries, and multiple people have lived all in different places around the world. So we're all over the place doing things. And so that gives us an opportunity to learn from our own experiences. You might be wrong. Like you might think like this should contribute a lot to a model, and it turns out to not contribute at all, or even contribute negatively to a model. But by implementing things, you start to learn.
And was there a moment where you look back and say, oh boy, if we didn't overcome this challenge, maybe SafeGraph wouldn't have existed? Was there like a make or break moment?
I don't know that there's a make or break, but I think I think in this particular in past companies I have, there's often like a a, a, a couple of core innovations that drive everything. At SafeGraph, it's been almost the opposite, where there might be not one innovation that's more than 1 or 2% of it, and it's like there's constant compounding things that you have to do to get a little bit better. Um, and even if you think of like a very big thing, like one of the things that we did is really create a model for understanding the entire world. We started in the US, and the US has a lot of standards, and it has its difficulties, but it at least has many standards that people could understand. As you move to the entire world, whew, the entire world is just incredibly diverse, and addressing systems are very different, even within many countries. If you think of within, let's say, a big country like India, the addressing systems can be very different, even in different states or different parts of India. And so it becomes a very hard thing to analyze all these things. And by the way, we still struggle with it. It's going to be that particular problem is going to be a problem that we're going to have for the rest of SafeGraph's life. We're always going to have to get better and better at that. And again, there's no one silver bullet. It's a series of things of just like slowly getting better at all these things.
That's extremely interesting. Actually, it reminded me of an example that we got negative feedback from a client. It was a weird case where in Canada there was inside a mall there was a gas station, and inside the gas station there was Tim Hortons. Uh,
Okay.
and I was wondering, did you have, or do you still have like definition problems? Because at that point, like it's even hard to say what the place is. Is the gas station the place? Is it a Tim Hortons? What if inside the Tim Hortons there's someone selling lottery tickets? Is that a
Yeah.
place?
Yeah, I think you do have definitional problems. And of course you have nested places. So you have places within places, you have places that are related to other places. So one of the things that we focus on a lot at SafeGraph, because we have a lot of customers that care about it, is parking lots. And sometimes you have a parking lot which serves one place, like the Walmart parking lot just serves Walmart. Um, but even there, it could serve something else sometimes. So, because you may have like a COVID response center in the middle of the Walmart parking lot for a brief period of time to help with public safety and public health, right? And so you may have even that particular, but then if you think of a parking lot of a strip mall, okay, that parking lot might serve those 14 places of a strip mall. Sometimes you have a parking lot in a city which could serve hundreds or thousands of places in that particular vicinity. So these things are related to one another. Of course, you could have a cafe inside of a Safeway. You could have pharmacies inside of things. You could have an ATM machine inside of something, right? You could have which could be inside of a bigger mall. So there's all these other nested things that happen. And of course, if you think of places as like cities or counties or districts or countries or continents, of course, you can have nested places all the way through, and you could have overlapping places, school districts and congressional districts and stuff. So it does get very complex.
But you're not expected to provide any sort of information, or it's not within your objective to provide the information of like who's served by this parkway, right? By this parking lot.
Well,
No.
yeah, I think so. I think if
Okay.
you want to find a parking lot, you might want to find the associated places that care
Okay.
about that parking lot. So if the parking lot is in a strip mall, you might want to say, okay, this parking lot is serving this strip mall, and these are the 14 stores in the strip mall, and here's some information about those 14 stores, so you could have a sense of like what's going on, why is that parking lot important, etc.
And why are parking lots important for clients apart from parking their cars?
Well, I mean, in the U.S. at least, and obviously every country is different, but the U.S. a vast majority of our built space is taken up by parking lots, and it's not always the most efficient space. Often they're extremely full at 2 hours of the day, and like maybe for something like 14 hours, they're basically completely empty of the day. And there's a lot of other interesting things about these parking lots, and there can be a lot of dual uses potentially. And sometimes this parking lot, there's a lot of really interesting things that are happening. There's a lot of people who study parking lots. There's a lot of people who buy parking lots. There's a lot of cities and counties who care deeply about this. It gives you a sense of like how you can move about in a particular place. If you want people to get to yourself by car, you have to have a way of them getting there and staying there by car. And not every city cares about cars, so maybe cities might be a little bit more pedestrian based. But the vast majority of cities, at least in the U.S., are very, very car centric in places in the U.S. And then you need somehow for them to get there, and those parking lots could be underneath the ground, which maybe takes up less lateral space. They could be over the ground. There could be a lot of other things, but they're there and they should be accounted for.
So the user would be someone that tries to calculate the parking opportunity somewhere, but also like a commercial real estate developer that's finding.
Yeah, and it could be a city and county that cares about some of these things. Could be environmental organization that cares about this. So there's a whole bunch of different use cases where you would want to care about understanding parking, transportation, a whole bunch of other things, and maybe that parking garage serves many different retailers, and you're trying to open up a nearby retailer. Okay, well, is it going to be easy for people to come to my cafe? Or are they going to have to like circle the block for 5 minutes before they want to come to my cafe? In that case, like they may make a decision not to come.
So apparent from your stories, but also if you visit SafeGraph's website, it's quite clear there's a wide range of use cases and a wide range of clients, of typologies of clients. Are there any major patterns? Like you'd say one industry has figured out how to use the right data and all much better than others?
I would say that the companies, the more product based a company is, usually the better it is at using data. And so that product could be an external product. So I'm making software for retailers, right? That's an external product. I'm making a product to sell to other people. And of course I need places data, and I can incorporate the places data from SafeGraph. It could be an internal product. I've got an internal product that I am building, but it's an actual product. It's not like a little analysis thing. I'm actually building an internal product for my internal real estate team, my internal decision team, my internal logistics team, whatever it might be. And I'm building these products internally. And the more they're product oriented, that means there's probably like a product manager, there's engineers on that product. The more they're product oriented, probably the more likely they are to use data. If it's like more analysts, they're trying to get to just some sort of answer on a question and move on. That is, we found to be a less good use of the SafeGraph data.
I'm not sure that addresses the question. I'll try with the opposite.
Okay. Yeah.
You get in touch with a lot of parts of the market and ways of using the data. Some are like more programmatical, completely automated. Some might have like a human in the loop, or sometimes even displayed, and it's like a case by case decision made by someone just informed by data, and that it probably applies vertical by vertical. The reverse of that question would be, do you see like an industry that you think will be massively transformed in the next 5 years by the use of data, and they haven't realized it yet? Like there's a lot of untapped potential there.
I think it's hard to find an industry that won't be massively disrupted by data. And you're going to have the disruptors and the disruptees that happen. And you certainly want to be a disruptor and not a disruptee. And so the more data oriented you are, the more likely you are going to be a disruptor. Doesn't mean you will be, because there's a lot of things to come into place. And the more likely you're going to be able to take market share. And that's true in healthcare. It's true in logistics. It's true in retail. It's true in insurance and in banking. You go down the list. Whether, in almost anything you could think about, the data oriented folks are the ones that are more likely to be the winners. Doesn't mean they will be the winners, but it means they will more likely be the winners that are out there.
Interesting. Do you see this? So I think that's consistent with some of the things that we've seen, and obviously you've been exposed to a lot more of it. But I'm wondering, we see one thing with a lot of sophisticated data teams. They have this big audacious goal, or that this huge decision that's been done manually for decades or centuries, and now they've embarked in this like 5-year project of making that completely automated until the end of time. And within that, with like huge budgets, lots of smart people, clear path to get there, there's like tons of barriers that are sometimes funny, sometimes sad, and most of the time unexpected things like well, I guess in the case of places, it would be like lots of streets where it isn't clear what the name of the street is, like something completely ridiculous.
Yeah.
Where you're like, the difference between that goal and that problem that's sort of keeping everybody stuck. A lot of the time is like transferring of data between multiple parties, and the security and the privacy implications of that, sometimes regulation. What do you think needs to happen to have for data to have full retail adoption?
Well, look, there's a lot of things that need to happen. So I think the first thing is as I mentioned earlier, like getting good at using your own internal data. So how do you get good at that? Are you building products on top of that? Or are you just doing analysis on it? The more you can productize it, the more there's actually something that's happening where it's like a real product. Again, it could be your own internal product if you're a big retailer or a hospital chain, whatever it is. But the more you are productizing that, the more you're going to be able to incorporate other types of data sources in the future. The more it kind of looks like an API, the better it's going to be internally. And so there's people who are going to more likely think in that way. There's an organizational piece of it. So if you think of Amazon, a lot of people admire Amazon for lots of different reasons, and I think there's a lot to admire about Amazon. One of the things that I think is one of the things that I admire Amazon for that maybe is a little less talked about is how they run the organization. And they were really one of the first companies to truly mandate that every service has to be a microservice, and essentially every single piece of code is essentially an API. And that gives you a lot of flexibility about how you manage your organization, and also makes it very easy to upgrade things, to make things better, to move things around. If there's a vendor that will do it better than something you did internally, you can go use the vendor. There's easy endpoints and et cetera. There's guardrails of how you can operate in. It becomes easy to for people to innovate because people are in that micro box. Going back to that earlier thing, so you know what you can do, and you're taking certain inputs, and you have certain outputs you have to deliver. So the more companies start thinking like that, and not just companies, but organizations, governments, et cetera, that think in a bit of a more microservices way, the better we are going to be long-term about using data.
So it's not necessarily a barrier per se, it's more of accumulated experience, and how do we iterate a lot through data-driven problems and sort of leave heuristics aside and just work a lot with that type of mindset and the type of problems that are.
Yeah. That's right. Now, I think it's becoming easier and easier to do, because there's a lot of information that's out there. There's a lot of people that have done it before that you could look at. You're hiring people from different companies that have done it. And then there's a lot more competitive pressure to do it today, because if you're not doing it, there's someone eating your lunch. And so there's a lot of, whereas maybe before there wasn't as much pressure to get it done.
And then this massive improvement in all sorts of AI technologies in the recent years, they're definitely making a
Correct.
lot of.
Yeah, obviously you've got all these great tools, whether they're database tools like Snowflake, there's some sort of analysis tool like Databricks. There's all the cloud services tools that are out there. There's places like Alteryx. There's visualization tools like Tableau or Esri or Mapbox. There's so many different tools that are out there to help you do your job better today. And if you think of a data engineer today versus a data engineer 5 years ago, that data engineer, even a good data engineer today, is potentially more capable than a great data engineer was 5 years ago. And if you think of a classic large organization maybe has a lot of ability to hire good data engineers, but maybe it may be extremely difficult for any of them to hire great data engineers. Maybe the great data engineers only want to work for the most innovative startups or the most innovative tech companies, and that leaves a large, well-known supermarket or some other type of retailer out of it leaves them the ability where they have to take the next level of data engineer, a good solid data engineer. But a good solid data engineer surrounded by these new tools is extremely capable.
Yeah, like 10 years ago, no matter how good of an engineer you were, the processing power would just have you wait for hours to do something
Correct.
extremely complex.
Or it was too expensive to go do anything or whatever it is. Yeah.
Yeah. You recently, SafeGraph launched a service. I think it's called, I don't know if that's that's a name, correct me, it might be a tagline, cross-shopping insights.
Yeah.
Who uses that? What is it?
So it's basically, if you think of a data company is really just about rows and columns, right? If you just to make it really simple, just think of a spreadsheet. And the rows are like the entities that you care about. In our case, we care about places, physical places, usually have like an address or something about them. It's like a store on 555 Main Street or something. And the columns are certain attributes about those places. So in our case, the column could be like the address, the phone number, the website, the store hours. The address could be an array. I mean, the column could be an array, like a store hours is an array. It's not just like one data point. But that's the type of thing. And so you're always wanting, as a data company, you essentially want to be always adding more columns and more rows, right? So you want to get more places that you care about, and that could be more geographies, or that could be within geographies. We're going to add, we didn't cover apartments, so now we cover apartment buildings or something, right? We didn't cover office buildings, now we cover office buildings. We cover warehouses, now we cover warehouses. Or it could be a new geography. We didn't cover Slovenia, now we cover Slovenia, or whatever it might be. Right. And so this is just another example of a new column that we have. In this case, the column is, in this particular case, the column is just for American businesses, because we just have the data on American businesses. But it gives you a sense of like people who go to this particular place, what other things are, what are these, what a high level of what these, where are the other shoppers doing when they go after they go to this place, before they go to this place. So you get a better sense of this place. Maybe this place is over indexed on Disney Plus and under indexed on Netflix or something.
Yeah, can you even say, for example, that let's say you have no access to any sort of demographic data. Can you look through patterns and say the people in this neighborhood Saturday morning, they're probably very young people, modern. Can you use that to determine?
I think there are lots of different things that one can do. I mean, and we don't particularly have something like that, but I think there's lots of different things to do to understand places. To me, the things that like I really care about that we don't have today are things like the number of bathrooms in a place or something. Like, we don't have that data today, and that's something like I would love to have, because I think that data could be like really, really valuable. Or like, what are the floors made out of in this particular place, right? That could be like really interesting and really valuable type of data. We have like the layout of the place, at least the very, very high level polygon of a place, but maybe a more granular layout could be really, really interesting and understanding for our customers. So there's lots of data that I would love to add about given places. You can imagine like some places have certain liquor licenses, or some places have other types of things that are out there. Those are the types of things like long-term we want to add. If you think of any given place could have 10,000 relevant attributes. If you think of your home, we don't cover homes today, but if you think of your home, there's like the number of bedrooms and the school district that you're in, and the walkability score, and what the roof is made out of, and maybe the type of soil content that's underneath your home, and a whole bunch of other kind of data points. And often when people are doing searches for homes, they're doing some sort of implicit search on like thousands of these different data points, and different data points might be different for people care about different data points for different things. Obviously, the price of the home is very important, right? The square footage, there's many, many, many different things that people care about. And that's true for every place. So you want to have as many attributes about a place as you can. But of course, you want those attributes to be accurate, because people are going to make decisions and rely on these attributes and these facts.
That's it. That's extremely interesting, and actually made me listening to you describing all the types of data points or facts you can have on a place, and a lot of them are things I have never thought about. And on some, I have some ideas of how they might be useful. On some, I don't. I was wondering, I imagine this is a challenge for your clients as well, right? So you can have like teams that say, have a clear idea on how to use data points ABC, have no idea why would anyone care about D, E, and F.
Yes.
Would you say there's a pattern around what makes a successful client successful, not successful as a business or outside, but in using SafeGraph data and deriving the relevant insights for their business? Is there some sort of understanding or capability or way they structure the data team, or place in which they put the data team in the organization, or any sort of pattern that comes to mind?
Well, first, as I mentioned before, the more product oriented they are, probably the more successful they're going to be with our data or any external data set that comes in. And certain organizations are extremely product oriented. If you think of like 1 to 100, certain organizations are like 100, and some are probably closer to 1 to 10. And so the closer they are to, let's say, 60 plus, probably the more likely they are going to be successful with the SafeGraph data, or I think with really most external data. And so if you're an organization, you want to figure out a way, if you're not that product oriented, to be more product oriented and not just be more like analyst related oriented that's out there. The other thing with data is there's a lot of humility that comes in the data world. You might think you need data about these 3 attributes, as you were mentioning earlier. And it turns out like actually one of them actually is very important, but there's these other attributes that are like maybe somewhat related to the ones you think you need, but actually are much, much more important for you. And so you sometimes need to try out a lot more data coming in, run your models, see what sticks, throw out the data that isn't, sometimes the data could be like negative actually, or adding negative value. So just because you came in with a particular hunch, or just because something worked in the past, doesn't mean it's going to work in the future. So there's a lot of different things you have to be changing. You need to be agile. And then, of course, you need to recognize that data changes. So even data about a place, let's say, your local cafe or something like that, that data goes stale very, very, very quickly. First of all, in the US, the average death rate of a place is 1% a month. In COVID, it was 3% a month, right? So you just have like places dying at a very, very high rate, right? The average death rate of a person is less than 1% a year. So you're just having a much, much higher rate of death, and in some ways of birth as well, of new places that are out there. So you're seeing a lot of creative destruction in places. And then of course you've got things like store hours. Well, store hours can change quite regularly. even normal times, store hours are changing often monthly or quarterly or something like that. But we're not living in normal times right now. Obviously, we've got COVID, so things are like really changing the store hours. In the United States, you have a labor crunch. So a lot of stores are actually shortening their hours pretty drastically right now because they can't hire people. My local Starbucks used to be open till 7 p.m. Now it's open till 3 p.m. because they can't hire people anymore. So you have to be on top of this data that's constantly changing, constantly moving around. Obviously, if you had price data, we don't do that much stuff with price data, though we're starting to do more there. You can imagine prices, just because of inflation, prices have been rising a lot. So that burger before that was $4 might be $4.50, might be $5, might even be $5.50 right now. And so you're just seeing a lot of changes with pricing as well.
I think this ties to the entity question, but you actually, when thinking about places that are born and places that die and places that change and places that transform, I would imagine this makes for a interesting, at the very least, technical challenge. Like, what do you do? How do you keep track of those changes? But then how do you manage them? How do you manage them in your database, and how do you communicate them to your client? You have you have lots of moments when you have to break a row and merge a row, and
That's right. So you have scenarios where places where you get it wrong and have to merge, or you have to demerge or something like that. But you also have a place, let's say a cafe, and the cafe went out of business. And then a month later, a new cafe, or maybe a gym, or maybe a bicycle store or something like that opened in that exact same location as the old place. And those two places are related. They're at the exact same address. They have the same footprint. Maybe it looks a little different today, but they're very related to one another. Yet they're very different. And so you need to make sure that your database model has a sense of what that is. And so for us, a place isn't just an address. Right? It's, if you think of a house, like, it wouldn't just be a house. It's just like, it's a house that Florin owns, and then later Auren might own that house. I might buy that house from you, and it's a different place because now I'm the auner of it, and I have a different way of going about it. And then, of course, a cafe is even more different. So if it was Florin's cafe and now it's Auren's cafe, it changes. And then, of course, if it's Florin's cafe and now it's Auren's bike shop, now it's very, very, very different. But it's still in that same location, so they're very, very related to one another. And so you need a database model to work all those things out.
how? Like,
First of all, you have to have a will to do it, and for at SafeGraph, like, our clients demand it, so it's really, really important to be able to do and to be able to track. And so we were one of the companies that were very involved in this thing called Place Key. Place Key is a join key where you can get like unique keys on a physical place, and that place could be 555 Main Street, Suite 904, and Suite 904 has a slightly different place key than Suite 903. They're related. There's a lot of things about it. And then, of course, if it's like Florin's law office at Suite 904, and then all of a sudden Auren takes over and it's Auren's accounting office on Suite 904, it should still have a very, very similar key, but different. And then those keys should somehow point to one another. So, okay, this is no longer here. This was here from January 1995 to October 2015. And then on November 2015, this new thing showed up here, and they're related to one another. So you need some sort of keys that point to one another to have people understand that.
that sounds like a crazy challenge to embark on. So one thought that comes to mind is that to build the perfect structure for what you're describing, you kind of have the prerequisite of having to know everything before, because
You don't have, it doesn't have to be perfect. There's no data that's perfect.
Sure.
Right? Data always has problems. Data always has holes. Data always has things that aren't true in it. And so, but you want to build something that's very, very, very good and usable. And then you want to have the will to keep making it better. What's your rate of improvement? Right now, like, our rate of improvement at SafeGraph is like 12% a month or something, is like we're improving the data. that's a pretty good rate of improvement. Maybe we could do better. Maybe we can get to 13, 14, 15, 16% a month or something. You don't want it to be like 0.1% a month, right? And so how do you keep improving something? How do you keep making it better? How do you keep, how do you, how open are you when you have something wrong? So we publish most of our bugs every month. We have a list of all the things that we get wrong. And people constantly say, like, what is your, what's your accuracy rate on a place? And we don't know. And people who tell you, like, our accuracy is 97.46%, like, there's no way to know these types of things. All I know is, like, last month, I had like 300,000 plus bugs in my data that we found. And I can pretty much guarantee you that this month we'll probably have at least 300,000 plus bugs in our data that we will find. So you're just constantly trying to make it better and better and better, and at some sort of good rate.
That's very interesting. If you'll let me tie it from a point from 30 minutes ago when you said starting in the US is a lot easier because there's a lot of standards. And then you mentioned place key and sort of, correct me if I'm wrong, place key is like adding 3 or 4 other dimensions to the lat long.
Yeah, I mean, place key is really just taking a messy address, which could be written in many, many, many different ways, plus maybe some like the name of a place, and converting it into a string. There's a lot of nice things about place key, particular because the string is like fits you on a geocode, like it's a hexadecimal system on a geocode that is really, really nice and easy. But just the very simple thing is taking messy data and converted to string. You can imagine another entity like a company or something, right? Okay, you write Microsoft, I write micro space soft. Someone writes Microsoft Inc. with a period. Someone's Microsoft Inc. with incorporated. There's maybe another company like Microsoft soft serve ice cream that's out there, right? So you ideally want to take this data, which could be very, very messy. It might be a name, it might be a URL, there might be some other data about this like company, and you want to convert it into some sort of simple string. Maybe it's a ticker symbol, MSFT. Maybe it's some other type of string and then now we have a string, which could be just an ID, it could be a number, right? And now we can easily compare with one another. So we can merge data, we can move data, because part of the value of data, and sometimes it's the most important value of data, is that you can join it with other data. So the more easily you can join your data with other data sets, the more valuable your data is, because now the ultimate consumer of that data can ask much bigger questions across data sets, and it's much easier for them to do that. So if you have data about physical places, you want to be able to join it with all other data about physical places. So that's where like the place key comes in. If you had data about companies, or you have data about products, or you have data about people, or whatever you have data of, you ideally want to be able to join that data with internal data, with other types of data, so that the data becomes really, really, really easy to operate on. And these join keys are really important. Often you'll have many, many different join keys, right? So if you have a join key about price, well, most companies around the world use the dollar, right? The dollar is a very, very good join key to use. If you have time, most people use Unix time. Unix time is an incredibly easy join key. It's very easy to operate with Unix time. If we have join key about space, we're probably using the meter, right? Which was if you know your history, which was basically relegated by Napoleon. So he basically forced us all to use the standardized space thing called the meter, and that's become an incredible good join key. Otherwise, we'd all have our own version of like, well, your foot or your hand is longer than my hand, and it becomes very, very difficult, or your step is longer than my step, and so it becomes very, very difficult to measure things. So I think all of these different join keys that we have in our life, sometimes we take them for granted, like temperature and stuff, but they become really, really important as we're starting to join all these data sets together.
Yeah, like language, or the other Napoleon huge decision, like walking on the right side of the street. And
yeah, exactly. Yeah.
But the convenient thing about both language and the right side of the street is that it doesn't necessarily need to change, right? It's just It's something we agree upon. This word means that, and then you'll understand, and you'll figure everything else out by looking at the context and so on. But it doesn't need to change at the pace of the technology. It will take maybe 1,000 years for the way we speak to change at the pace we see today, and in a field like data science. Um, so, and I think this poses a very interesting challenge where you have the difficulty of coming up with a standard where maybe you don't need to be Napoleon, but it's not that far, right? It's it's close enough to being Napoleon.
Well, it's much easier to be Napoleon. If you want to make a standard, it's great if you are Napoleon. If you've crowned yourself emperor of Europe, it's a lot easier to get people to adopt your standard than if you're just, Joe Schmo somewhere who thinks this particular thing is a good idea. But that doesn't mean that Joe Schmo somewhere can't create a standard. Where standards are being created all the time. There's many, many different standards. I think like basically a Joe Schmo kind of created Unix time, which has become like the absolute standard of how people measure time, how people think about time. It's a very, very, very important standard. And it's not like, eventually I think many governments have blessed that standard, but I think from the history that it was not, it wasn't like, the Politburo somewhere saying like this has to be the standard. And the thing about standards is they don't have to be perfect. So if you think about Unix time, I think it starts January 1st, 1970 or 1971, right? So before that, it's like negative time, which is really, really weird and odd. And, it has a lot of other weird issues with it. Or if you think about the QWERTY keyboard, like it obviously has a lot of problems with it, like why aren't the keys in alphabetical order? Like kind of makes no sense. And so there's all these different types of things that are out there that are standards. They don't have to be perfect, but once they become widely adopted, they tend to have really, really great use. And so the fact that like in most of the world, we think of temperature the same way, or most of the world, we think of time and space in a very similar way. We all measure the second in a very similar way around the world. Like this is really, really valuable. And the fact that you and I are having this conversation in a common language right now is, in some ways, English has become essentially the standard for business around the world. And so there's lots of really important standards that have arose. And of course, is English perfect? No, English is like the worst language. Like when I'm teaching my kids to read, it's like impossible to understand. But we've picked it as kind of a standard. And I think having these standards really work out really well.
I understand your examples perfectly, and I think so. For example, English has the benefit of being extremely simple in writing, right? It's not like 1,000 verbal tenses, or
Yeah.
probably nobody would pick up English outside the English-speaking countries if that were to be the case. But in a lot of with a lot of standards, it's not like the Unix and the QWERTY had the benefit of not having a mainstream standard that they had to replace. If you were trying to replace the QWERTY standard with something like objectively better, right?
I think that's hard. That's hard because it's already serving a good purpose. It's the QWERTY standard is free. I don't have to pay a license to the QWERTY holder somewhere, right? Every time I want to create a keyboard, so it's free. So it's hard to compete on price with free, right? It works pretty well. Like all these people have invested a lot in how to type and use it. So it actually would be even harder for most people to change it. So I think it's very, very difficult to attack a standard that both is free and already mostly solves, so yes, are there better standards potentially objectively than Unix time? Almost certainly, but Unix time is free and easy to use and works pretty well. So it seems unlikely that that's probably the best place to focus your time on. And the perfect's the enemy of the good. It's good enough. It works. Could it be better? Sure. Maybe in certain kind of core use cases, there could be something in like particle physics where it doesn't work at all. And then we need a different standard for those use cases. But for the vast majority of use cases, it works. And then, then you move on. There are some standards that are either not really very, very good at all, and then there could be open to attack, or they're expensive. They're not as open. And so in those cases, I think you also could be, or they just take a really long time. I need to get a new ID for this thing, but now I have to wait 3 years for some government entity to bless it or something. In that case, it maybe the standard works, it's free, but there's a time-based reason why a new standard could work better.
Got it. So it has to be like a major barrier that you remove apart from being objectively better.
Correct. There's a famous XKCD, comic where, someone's like, there are 13 standards and they're all bad. My idea is I'm going to create a new standard. And then like the next panel is like, there are 14 standards and they're all bad. Right?
Yeah. Oh, I guess they're, as long as they're a standard, they're much better than they're not being a standard.
Yeah, exactly.
That's the initial first condition.
Exactly.
I was curious. You wrote an article a while ago that was actually, to me, it was really helpful. It came at a point where we were executing a pivot and trying to understand the waters we were in. And your article called the DaaS Bible. It helped me a lot understand the paradigm of a data company. But you did an interesting thing. You coined the term DaaS, or you proposed the term DaaS, and I was wondering, why do you think it's a different breed of companies? Like, why do we need a different term for it?
I don't know, but I coined DaaS, but maybe more popularized the term DaaS, data as a service. Data as a service is really interesting. Again, like if you think of DaaS companies versus SaaS companies, 15 years ago, nobody had any real good language about SaaS companies. And now there's all this great language. It's really easy to understand them. There's an LTV to CAC, and there's all these other things that we think about when we think about SaaS organizations, these software as a service organizations. And as I mentioned, there's well over 1,000 SaaS companies that are worth over $1 billion. And so it gives us a real good sense of what's going on. And we have a long historic understanding of the margins of these companies and growth rates and all this other types of stuff. In the data companies, it's much less known, especially maybe there are data companies that have been around for 40 plus years, and these are maybe a little bit sleepier and they're a little bit more well known and they're covered by, stock analysts and stuff like that. But if you're investing in a data company, and so if you're an investor and you care, or you're someone seeking investment, you're an entrepreneur who's seeking investment in data companies are different. There's a lot of weird things in data companies. In a SaaS company, you often from day one, your margins look great on paper. They might not actually be great, but just the way the accounting rules work, at least in America, your margins look really, really good, even though actually they're probably not in reality that good. In the data company, it's almost the opposite, where if you're buying data in any type of way, that buying the data usually goes above the line in a data company. And so it immediately hits your margins. So it could be like the first year of operating, it looks like you have like 10% margins or something. But in reality, it's a fixed cost. And so that if the company continues to grow, that 10% margin could end up being an 80, 90% margin company over time. And so it's very, very hard for investors. Like no investor wants to invest in a company that's 10% margins or something. And so it's hard for them to understand like these things aren't the same. It's not an apples to apples comparison between SaaS and DaaS. There's a lot of similarities. There's a lot of similar ideas between SaaS companies and DaaS companies, but there's also some very, very, very important differences. And it's helpful for both an investor and an operator to have a common language. Again, going back to that standard, having a common language to be able to describe things so that they can make proper investment decisions.
That's very interesting. Let me ask you a specific question to sort of go deeper on that. If you had, let's say you have a good friend that's a VC, has never made a data investment, doesn't agree that data companies are a different breed, how would you explain the main differences that he needs to be aware of, and how would you sort of sell him on the idea because you care about him? And
Well, I mean, first of all, I don't think investing in data companies is for everybody. So certainly something I like to do, and I think is I think is good. But if you've been successful investing in SaaS companies, you could just keep investing in SaaS companies. No reason to invest in data companies. You'll do plenty well, just focusing on SaaS companies, or focus on your strengths that are out there. So I don't think there's necessarily a need for you to have to understand all these different things that are there. But for people who want to understand that, who care deeply about data, then data is different. And so there's a lot of different nuances. As you mentioned, I try to write this piece, the DaaS Bible, to help you understand some of these very, very different nuances. Understanding, where are you really a data company, or you say you're a data company, but you're actually an application company built on top of data. Are you backward looking? So you're focused on facts. You're focused on, like, this is true, this is history. That would be like more like SafeGraph. Or are you forward looking? Are you trying to make some sort of prediction of the future? Are you taking data as an input and creating some sort of score, like, will somebody pay back a loan or something like that, or some other type of thing, right? And so you have many, many different types of companies that are out there. So giving you a language about how to put them, how to type those companies, how to put them in some sort of quadrant for you to analyze, how to understand their economics, and also, like, helping those data companies to make the right choice. Sometimes I've seen data companies where they want to make their margins look better in the short term. And so you could do these very, very odd things, like if you maybe you built a crawler on your own and go crawl some sort of data, and maybe because you built it on your own, like, all that falls below the line, or somebody else already has this crawler built, right? And you could just buy that data for them at like half the price, and that data goes above the line, kind of hurts your margins, but, like, actually could be a better long-term business sense to go do. So you have to understand that, and then of course you have to be able to explain that to both investors, employees, and other kind of core stakeholders in the business.
Okay, that with the little understanding of accounting that I have, I think it made sense. I'll go revisit my college accounting book, but I think it made sense. And let's take another friend. So there's a friend. It's a VC that wants to invest into data companies. He's sold on the idea, sees a lot of the things that are happening in the market. How would you advise him to pick a good data company versus a bad data company? What should he be aware of? What should he pay attention to?
Well, if you have an investor who's looking at data companies, it's hard to find what a good data company is, just like it's hard to find what a good software company is. And it could be based on the stage of the company, based on the market that they're going after, based on the product that there is, et cetera. What are you looking to do? And there's companies that are trying to do lots of different things. There are companies that are extremely tech heavy, and this is true both for software and for data. They're very, very, very tech heavy, and it's a very, very hard tech lift. And then you need a certain amount of expertise to analyze that tech. That's not always so easy to do. And there's ones that are maybe more business strategy heavy, and maybe a typical investor might be easier for that investor to analyze the pros of that and the strengths of that particular company that's out there. And so. But I don't think there's like any one size. Just like it's just like SaaS companies. There's so much diversity in SaaS companies. They're doing so many different things. They're going after different types of markets. Sometimes you actually have to be a market expert to analyze. If they're going after the healthcare market, you may actually have to be a healthcare expert to analyze it, not a software expert. So it really depends on the company. It depends on a whole bunch of different things. Every company is very, very, very different. So it's hard to provide like a particular heuristic that you use for everything. And of course, the more early stage it is, the more the founders count. If the company's already doing $1 billion in revenue, maybe less the founders count, right? And more you could so there's lots of different things that you can analyze things on.
The SaaS, the yes, in the past do have this huge advantage of like we've seen success in a lot of shapes and forms, and at least some heuristics can be inferred.
Yeah, that's right.
Yeah. Okay. Um, are you good if we finish with a couple of personal questions that I prepared in
Sure.
advance?
Let's do it.
Um, so here goes. What's something you were absolutely convinced it's true when you were 30 and now you think it's completely wrong?
That's a good question. Well, maybe the flip advice thing is I probably was very convinced that things had to be done in person, much more so, and now I have I can see the strengths much more of having a remote first company.
Interesting. Is there something that has changed in how you see teams? Like there was something behind the conviction of you need face-to-face interaction?
I think there may have been obviously people have a lot more experience of being remote first, and there's a lot more written about it, and there's a lot more education about it, and et cetera. And there are a lot more tools to do it. But I also think it may have just been a failing of mine before of not being able. There were certainly many remote first companies that have been very successful, and of course, lots of great open source communities that have always been remote first that have been successful for a very, very long time. And I think I just didn't see it when I was 30.
Okay. Yeah, I have two more. What's a data company you'd love to see but probably doesn't exist?
So what's like a data set essentially that I'd love to see, or
Sure. Yeah, let's go with that.
yeah, well, I think one of the most important data sets to make available is more medical data that's out there, and there's very, very little medical data. There's very little data about anything, and not just medical, but any type of health data. So people are making health decisions like, what should I eat? This is a decision that all of us probably think about all the time. And I want to eat healthy things. We don't know anything today. We really don't know anything. Anyone who says we know something, really, we don't. There's very little data to back anything up. For all we know, you should be on like a full-time chocolate cake diet. We just don't know very much at all. And that's because we just have almost no data on things about it. And so I'd like to see a lot more data being collected. I think in the past, there was this very, very hardcore trade-off between privacy and making data available, and everyone knew making more data available would make society better and would save lives. But at the same time, this data is very, very private, and we don't want the data to be out there. We've made in the last 10 years, there's been a massive amount of strides in privacy technology. We have differential privacy, we have homomorphic encryption, we have all these other really great things. So now, like we can have our cake and eat it too. We can have full privacy where everyone is 100% protected, and we can make data available by asking deep questions about the data without seeing the underlying data. So we're at a point right now where we could see a huge renaissance in things like health. And if people have the will and the brave, they're brave enough to actually go out and do it.
And we make a good enough job at explaining how privacy works today and why.
That's right. That's right. There has to be a lot of education that's out there because it can be very, very fearful that's out there. But so many people can have better lives. So many lives can be saved. People can live much better. People can live longer. People could be much, much happier. Society will be better if we can take that next step. And I'm very, very excited that we will be able to take that next step soon. And if certain societies choose to take that step versus others, those societies will end up being much, much, much better off. And so we'll also starting to see differences in societies as well.
And a lot of it is also needs to be enabled by the government.
Absolutely. Government has to make it safe to go do that. And a lot of times the government is the one that has the data. Yeah. So they can, if you think of like the NIH in the UK, they have amazing data, and they make some of it available. And that's great. And they make way more of it available today than they used to. That's great. But there's a lot more that can be made available in a privacy safe way.
I can't wait to see that happen.
Yeah,
I'm sure
it's
will.
going to be amazing. It's going to be amazing, and it's going to affect every single person in the world. It's going to make every person, not just rich people, not just people who live in the UK. If the NIH makes that data available, every person in the world will benefit.
Yep. And it doesn't have to start with the hardcore stuff. It can start
Correct.
with your watch and all the IoT.
That's right.
Yeah. Okay. Switch of topic. What would Auren have done if he lived in the 1800s?
I have no idea. That's a good question. I probably would not have been as suited to be there. Maybe be a painter would be great. I feel like there's a lot of amazing painters that went there. If it was the very, very early 1800s, I would have loved to be in America. Kind of like at the early foundings of America. I still think America, the United States, is the best place to be. But then it was really at the genesis of being the best place to be. I would have certainly loved to have seen it and maybe done a small part in propelling it in that way as well.
But like when you say painting, you mean painting, or like not sitting on the street and 2x2 matrices to people that.
I mean, I either being an actual painter, I have no good artistic skill, so I don't know that I would have been a good one. I don't think I would be competing with Matisse or Rodin or anyone like that. But I'm maybe fairly good at logistics and organizing things. So maybe somehow I was organizing things in the early American experiment or something, or helping build the first railroads, or some other thing that happened out there. If you think there are certain data companies that were built in the 1800s.
Yeah.
So if you think of Dun & Bradstreet, Abraham Lincoln worked for Dun & Bradstreet. It was built in the 1800s, in the mid 1800s. And so you have a lot of like historical types of companies that have been around for a very, very long time.
Yep. The concept was there.
Correct.
I think he walked down the street, right, and talked to every shop owner. Something like that. Was that the data collection method?
I don't know exactly, but I wouldn't be surprised. And so
he was crawling.
Yeah, exactly. He was crawling.
Yeah, awesome. Thank you so much, Auren. This was amazing.
Thanks, Florin.
Thank you for receiving my questions with and addressing them with being so open and thoughtful.
Well, this has been great. Thank you so much.
Thank you.